reflecting. Let's look at the definition. Keywords here, it's the mirror image. Here's the rules. So this is for reflecting across an axis. So note with this sign here, it's a negative f of x. And note also when you have the f of negative x. Okay. Next is symmetry. I'll give you a chance to read the rules here. So key words here, it's the negative x also, which is the replacement, and the negative y, which is the replacement also. Okay, so let's try an example. So you have here y is equal to square root of x. So this is half of the parabola that is facing to the right side. So if you want to reflect this with respect to the x-axis, you're going to take the other half, which is y is equal to negative square root of x. Okay. So following the rule from the one that we've shown you a while ago, it says the graph of y is equal to negative f of x is the same as the graph of y is equal to f of x reflected across the x-axis. So this is exactly what we're doing here. So we have the positive and we have the negative. Positive here for the red curve and the negative for the blue curve. So this is reflecting across the x-axis. So we can draw the x-axis here, y is equal to 0. And that's exactly the reflection line in green line. So from the definition also, it's like a mirror image. So exactly you can see the red parabola, it's mirrored across the x-axis, the green line here, to the blue curve. Okay, so let's try another example. What if you have a negative here inside? Okay, that would be on the other side, and the original form would be just square root of x. So in this case, you can see that the positive and the negative, it's inside your radical sign. So this one is reflected across y-axis. That should be x is equal to 0. Would be the y-axis. This is the reflection line. So the red curve actually is mirrored going to the violet curve or the purple curve. It's just the same way as if you have this purple curve and you want to reflect that to the other side, you just put a negative inside the radical sign. So states the rule from the reflection across an axis. It says the graph of y is equal to f of negative x is the same as the graph of y of f of x reflected across the y-axis. So that would be the reflection. So across an axis. So that should be across y-axis. Next, let's go to another example. Okay. So in here, this is the symmetry now. So if you're looking at symmetry with respect to an axis, so the rule said the graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in an equivalent equation. So if we're going to replace our x with a negative x, that's according to the rule, it gives you exactly the same curve. So that would be the symmetry is on y-axis, so that should be x is equal to 0. So as you can see, symmetry can be defined actually as, I'm going to cut this with a horizontal line. It's the distance or the symmetry of the line or line of symmetry. It's actually the distance from that line going to the curve. It's the same distance going to the other side of the curve. So from here going here. So actually it's the same distance. Again, from the line of symmetry going to a point to one of the side of the parabola is the same distance going to the other side of the parabola. So that's symmetry there. Okay. So in this case, the line of symmetry is on y-axis. Let's have another example. What if you're going to have a power of 2 for your y here? So the parabola would be actually facing to the right side. So the opening is going to the right side. So where's the line of symmetry here? So let's follow the rule. According to the rule, the graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation. So let's try that. Replacing y with negative y. So the red turns to purple parabola, so it means they are just equivalent equation. So that's exactly the second rule of symmetry. So therefore, our line of symmetry here is on the x-axis. So that's y is equal to 0. So as you can see also the shape of the other side of the parabola, it's exactly the same shape on the other side. So that's how you look at symmetry also, aside from uh, the distance that you're going to pick from the curve going to the line of symmetry, and from the line of symmetry on the other side of the curve, it should be equidistant. So that's another uh, definition for symmetry. Okay. Yeah, so let's try another example. Okay, so let's have a circle here. Okay, so we can see from the circle, applying the rule, you will get symmetry here for x-axis. You can see that. And then you have symmetry also for the y-axis. Okay, so this is when you actually replace your x-axis with your x, or variable x, with negative x. So the equation is just the same, and you'll have symmetry on y. And then when you're replacing your y with negative y, then you'll have an exact the same equation. So it's symmetrical to your x-axis, or with respect to your x-axis. But there's one more symmetry here, and that would be the point of origin. So why is it the point of origin is the third symmetry here? Because when you cut this with a diagonal line, again, this is a diagonal line. The other definition of symmetry is from this point going to this point is the same distance from this point of origin, going to the other side of the circle. Again, the distance from here going here is exactly the same distance from here going there. Exactly, that's the radius. So that's why the symmetry is at point of origin. So in this example, we have three symmetry here. We have the y-axis and the x-axis, and also the point of origin. Again, three: x-axis, y-axis, and the point of origin.